Object-oriented paradigm. The object-oriented paradigm took its shape from the initial concept of a new programming approach, while the interest in design and analysis methods came much later. Analysis and design paradigm is the logical result of the wide adoption of programming languages. Introduction to paradigm. Paradigm is a significant methodology for the development of any software. Most of the architecture styles or patterns such as pipe and filter, data repository, and component-based can be implemented by using this paradigm. Object. An object is a real-world element in an object-oriented environment that may have a physical or a conceptual existence. Objects can be modeled according to the needs of the application. An object may have a physical existence, like a customer, a car, etc. Class. A class represents a collection of objects having same characteristic properties that exhibit common behavior. It gives a blueprint with a description of the objects that can be created from it. Encapsulation. Encapsulation is the process of binding both attributes and methods together within a class. Through encapsulation, the internal details of a class can be hidden from the outside. Polymorphism. Polymorphism implies using methods in different ways, depending upon the instances they are operating upon. Polymorphism allows objects with different internal structures to have a common external interface. Relationships. In order to describe a system, both dynamic and static specifications of a system must be provided. The dynamic specification describes the relationships among objects, for example message passing. And static specification describes the relationships among classes, for example aggregation, association, and inheritance. Message passing. Objects in a system may communicate with each other by using message passing. Composition or aggregation. Aggregation or composition is a relationship among classes by which a class can be made up of any combination of objects of other classes. Association. An association is a group of links having a common structure and common behavior. Association depicts the relationship between objects of one or more classes. A link can be defined as an instance of an association. Inheritance. It is a mechanism that permits new classes to be created out of existing classes by extending and refining its capabilities. The existing classes are called the base classes / parent classes / superclasses, and the new classes are called the derived classes / child classes / subclasses. The subclass can inherit or derive the attributes and methods of the superclass, S, provided that the superclass allows so. Analysis. In object-oriented analysis phase of software development, the system requirements are determined, the classes are identified, and the relationships among classes are acknowledged. The aim of analysis is to understand the application domain and specific requirements of the system. The result of this phase is requirement specification and initial analysis of logical structure and feasibility of the system. The three analysis techniques that are used in conjunction with each other for object-oriented analysis are object modeling, dynamic modeling, and functional modeling. Object modeling. Object modeling develops the static structure of the software system in terms of objects. It identifies the objects, the classes into which the objects can be grouped, and the relationships between the objects. It identifies the main attributes and operations that characterize each class. Dynamic modeling. After the static behavior of the system is analyzed, its behavior with respect to time and external changes needs to be examined. Dynamic modeling is defined as a way of describing how an individual object responds to events, either internal events triggered by other objects, or external events triggered by the outside world. Functional modeling. Functional modeling is the final component of object-oriented analysis. A functional model shows the processes that are performed within an object and how the data changes as it moves between methods. It specifies the meaning of the operations of object modeling and the actions of dynamic modeling. The functional model corresponds to the data flow diagram of traditional structured analysis. Object-oriented design. After the analysis phase, the conceptual model is developed further into an object-oriented model using object-oriented design, OOD. Technology-independent concepts in the analysis model are mapped onto implementing classes, constraints are identified, and interfaces are designed, resulting in a model for the solution domain. The main aim of OOD design is to develop the structural architecture of a system. OOD design can be divided into two stages: conceptual design and detailed design. Conceptual design. All of the classes required for the system's construction are identified. Class diagrams are used to define the flow of events. Interaction diagrams are used to emphasize interactions between classes. Detailed design. In this stage, attributes and operations are assigned to each class based on their interaction diagram. State machine diagrams are developed to describe the further details of the design. Design principles. Principle of decoupling. In a new design, tight coupling can be eliminated by introducing new classes or inheritance. Ensuring cohesion. A cohesive class performs a set of closely related functions. A lack of cohesion means a class performs unrelated functions, although it does not affect the operation of the whole system. Open-closed principle. The system should be able to extend to meet the new requirements. The existing implementation and the code of the system should not be modified as a result of a system expansion. That's all for today on Object-Oriented Paradigm. Thank you for watching.